Okay, so now that we have a formula in hand, let's take a look and use it. Again, it involves, here's the formula, it's the distance. I'll use the square root version, is x2 minus x1 squared, y2 minus y1 squared, all of that under a square root. And so all we have to do is label our points, throw them in there, take care of our radical, and we're done. So for the first example, how about we just call this x1 and y1 since it's the first point that's given, and we'll call this x2 and y2 since it's the second point that's given. So coming over to my formula, the distance between these 2 points will be x2 minus x1, we're going to square that, plus y2 minus y1, we're going to square that, and then we're going to take the square root of that whole entire operation. So now we just do an evaluation. A 2 take away a negative 2, well that's 4. 7 take away a negative 3, that's 10. So we have 4 squared plus 10 squared, all of that underneath the square root. 4 squared is 16, 10 squared is 100, and so we're basically looking at the square root of 116. Okay, so there's our answer at the moment, but we have to make sure that this is simplified. So if we kind of break down 116, I know 2 goes into there, and I believe 53 times. So both these are prime, they're not nice square roots. So our final answer is the square root of 116. So that's how far that is. And if you want, you can bust out a calculator and get a feel. It'll be really close to 11, right? Because we know the square root of 121 is 121. And so this is really close to that. So, you know, it's probably like 10 points, 10.8, 10.7. Bust out a calculator if you want to know for sure. But there's a nice exact answer. All right, so before you start thinking, I'll just plot these and use what you showed me and just plot it off, right? Here's how I can almost force you to use this formula. There's fractions, right? First of all, it's hard to graph fractions, and it's kind of hard to see the little distances between those fractions. So we're almost forced to remember and use this formula. So I guess I got to do that to you guys. So here's my x1 and my y1. Here's my x2 and my y2. So we just plug them into the formula. So x2 minus x1, we're going to square that. Add that to my y2 minus my y1. And we're going to square that and then take the square root of it. Okay? So in order to keep going, we need a common denominator. So this is 2 over 2. So let me do some scratch work. This is negative 1/4 minus 6/4, which becomes negative 7/4, right? Squared. Over here, we already have a common denominator, so that's nice. This basically becomes 4/3 and squared. And this is still underneath the square root. This is 49 over 16, and this is 16 over 9. All right, and the square root. So now what we have to do is find a common denominator for this. I think there's really nothing nice. 16 and 9, yeah. So basically, how about we do 9 over 9 over here and 16 over 16 there. So 49 times 9, 1, carry the 8, that's 36. 441 over whatever 9 times 16 is. I'm going to just keep it as a product. Plus 16 times 16, 6, carry the 3, that's a 9. 6, 5, 1, 256 over 9 times 16. Whew, okay, so crazy fraction work. Now we have 441 times 256, 697. So we have 697 over 9 times 16, and we got the square root of that. So there you have it, right? So we've got it going there. So we need to simplify this now. I believe if we break this up, right, we can consider the square root of 697 all over the square root of 9, the square root of 16. So I don't know what the square root of 697 is, but I do know the square root of 9 is 3, and the square root of 16 is 4. So I know for a fact we have a 12, but the 697, I believe a 3 goes in. Nope, yeah. Nope, 3 doesn't go in there. 2, 7. I don't get anything really nice. So I'm going to go out on a limb here. 7, 63. Oh, I think 7. 7, that's 7, 8, 9. 9 times 7 is 63. Yeah, that's 67. Nope, 7 doesn't go in there. Yeah, so how about we go on a limb and just say that that's a prime number. Alrighty? So if I find out later, I'll come back and let you guys know. But there you have it. So again, a nice exercise of the formula. Nice exercise of finding common denominators, some good fraction work, some good square root work where we're taking the square root of a quotient, so I can do the top and the bottom. Taking the square root of a product, I can break it up. So I'm just trying to do as much review as I can within the context of another problem. But there's your distance formula. All right, use it. Make sure you know it. It's very important for those of you moving into college algebra and calculus. Talk to you guys later. That wraps up section 10.7.